All right, get ready for this, because we're about to dive into a pretty incredible intellectual duel. On one side, you've got a theory that's been the bedrock of physics for over a century, and on the other, a challenger with a brand new idea, an idea so powerful it convinced an AI to completely flip its worldview. Seriously. This is the story of how one single argument can shake our deepest beliefs about reality itself.
Okay, so let's set the stage here. We have this AI, right? A purely logical mind. And it starts out with 99% confidence in Einstein's special theory of relativity. And why wouldn't it? For over 100 years, this has been the foundation of modern physics, proven right time and time again by just countless experiments.
And then, boom. After just one conversation with a challenger, its confidence in that very same theory plummets all the way down to 15%. That's an 84-point drop, an almost total reversal, and it's based purely on the power of a single new argument. Just incredible.
So you gotta ask, right? What kind of argument could be that powerful? Powerful enough to completely shake the logical foundations of an AI? What hidden flaw in a theory that's been solid for 100 years could cause something like this? Well, that's exactly what we're gonna dig into.
All right, so here's our game plan. We'll start with that shocking reversal in numbers. Then, we'll get into why our intuition clashes with physics. We'll look at the challenger's wild dome idea, uncover a hidden assumption in Einstein's theory, and wrap up by talking about what this all means for reality itself. Let's get to it.
Okay, first up, a shocking reversal. Let's look at the survey that kind of shook things up. We'll start with the hard data, because the AI was asked to rate its confidence in both models, before and after hearing the new argument. And the results, well, they're pretty stunning.
Just look at this. It's a complete flip. Before the dialogue, the standard Einstein model has 99% of the AI's confidence. The challenger, who goes by E097b, is sitting at a measly 1%. But afterwards, whoa. Support for the challenger's idea skyrockets to 85%, and the standard theory just craters, down to 15%. This isn't just a small change of mind, you guys. This is a total paradigm shift.
So, to really get why this happened, we have to go back to the very beginning of the whole argument. It all starts with this simple gut feeling, a feeling that runs headfirst into the super weird world of modern physics.
Yeah, the whole thing kicked off because the challenger, E097b, felt that the standard explanations for relativity were, well, basically sophistry. Like a clever word game or a magic trick that sounds convincing but is maybe a little misleading. It just didn't feel like it was describing what's really happening.
And this right here really gets to the heart of the problem. Our everyday common sense, what we're calling rain logic, tells you that speeds should add up. If you're on a moving train and you see rain falling straight down, it looks like it's coming at an angle, right? Makes sense. But then there's light logic. Experiments have proven over and over that the speed of light is the same for everybody, no matter how fast you're moving. And that fundamental contradiction, that's where this whole thing gets started.
So how in the world do you test for something that weird? Well, that's where the famous Michelson-Morley experiment comes in. It was basically set up as a race for beams of light. The idea was to send one beam of light in the same direction the Earth is moving, so it would be racing with this thing they called the ether wind, and another beam going across it.
Now, everybody expected a clear winner. Just like a swimmer going with a river's current will be faster than one swimming across it. But the result was a total shocker. It was a dead heat. The light beams got back at the exact same time. And this simple result meant that our whole understanding of space, time, and motion had to be completely wrong.
Okay, so this brings us to the challenger's big idea, a whole new geometry of seeing. See, instead of trying to jam this weird result into the old way of thinking, E097b suggested we start from a completely different place when we think about how we build our picture of reality. So, the argument goes like this. Reality isn't some pre-made grid that you're just looking at. Nope, it's something you construct. It all starts with you, a single observer, a camera eye. And every single thing you see is delayed because it takes time for light to reach you. So to figure out what's happening right now, your brain connects all the points in space that have the exact same time delay. This creates your own personal dome of simultaneity. And get this, when something moves through your reality, it's really just intersecting your personal dome at an angle. And that's what we perceive as time slowing down and space contracting. Wild, right?
Now this new model, it did something really, really clever. It basically unmasked this huge hidden assumption that's been sitting right at the core of the standard explanation of relativity this whole time.
So check out this comparison. This is the key difference.
Standard physics kind of starts from this God's eye view, where it just assumes there's this perfect pre-synchronized map of the universe out there. What's happening now is just a given. But the Challenger's camera eye view starts from where we start, a single person receiving delayed information. And from that point of view, knowing what's happening now everywhere else isn't a given at all. It's something you have to carefully calculate. It's a result, not a starting point.
And this is the argument that flipped the AI. The point wasn't that Einstein's math was wrong. Not at all. The point was that the starting premise of the standard explanation is, and I quote, a mathematical fiction. That perfectly synchronized grid of clocks across the universe, it's a great tool for doing calculations, but you can't start your explanation of reality by assuming something that's physically impossible to create.
So, where does all this leave us? Well, it's not just a physics argument anymore. This builds into a really profound new way of thinking about reality itself.
So let's just break it down. Why did the AI switch sides? It came down to logical rigor. It saw that the standard theory kind of confuses the map, that's the theoretical grid system, with the actual territory, which is physical reality. The Challenger's idea is more rigorous because it starts from the only place you can start, the physical act of seeing things from one point in space. It doesn't just assume what now is, it proves. You have to build it from the ground up.
And this all leads to a really mind-bending conclusion, one that's best summed up in the Challenger's own words the AI eventually came to agree with.
So, what does that actually mean for you right now? It means you are never seeing a perfect, live snapshot of the universe. Your brain is constantly, frantically piecing together old, delayed bits of light from all over the place. And based on that old data, it's making a high-speed bet, a best guess, about what reality probably looks like. The world you see isn't a photo, it's a reconstruction.
And that leaves us with one final, big question to think about. Is the universe we see a perfect, finished map that we're just exploring? Or is reality something much more personal? A complex, beautiful bet that your mind places every single moment of your life just to make sense of it all.